Study Section 2, Sampling Distribution of Statistics. Introduction. In the previous study session, population and sampling was discussed. Imagine that you have a large population to study and the description of its characteristics is not possible by census method. Then, in order to make statistical inference, samples of given size are drawn repeatedly from the population and statistic computed for each sample. The computed value of a particular statistic will differ from sample to sample. This implies that if the same statistic is computed for each of the samples, the value is likely to vary from sample to sample. Learning outcomes for study section 2. When you have studied this session, you should be able to explain the concept of a sampling distribution, explain the concept of standard error, differentiate between standard error from standard deviation. Concept of a sampling distribution. The following are some concepts of sampling distribution. Sampling unit. Elementary units or group of such units which, besides being clearly defined, identifiable, and observable, are convenient for purpose of sampling are called sampling units. For instance, in a family budget inquiry, usually a family is considered as a sampling unit since it is found to be convenient for sampling and for ascertaining the required information. In a crop survey, a farm or a group of farms owned or operated by a household may be considered as the sampling unit. Population. The collection of all units of a specified type in a given region at a particular point or period of time is termed as a population or universe. Thus, we may consider a population of persons, families, farms, cattle in a region, or a population of trees or birds in a forest, or a population of fish in a tank, etc., depending on the nature of data required. Population distribution. The population distribution is the distribution of values of its members and has been denoted by mu, variance, and standard deviation. For example, a population consisting of the numbers 0, 2, 4, and 6 as mean is equal to 3 and standard deviation is equal to √5. Definition. All possible samples of size n. Let a population consist of n elements. 1. If a random sample of size n is selected from the population with replacement, then there are n raised to power n possible samples of size n that can be drawn from the population. 2. If a random sample of size n is selected from the population without replacement, then there are n Cn is equal to n factorial over n factorial into bracket n minus n factorial possible samples of size n that can be drawn from the population. Example: a population consists of the numbers 0, 2, 4, and 6. List all possible samples of size 2 that can be drawn. 1. With replacement. 2. Without replacement. Solution. 1. The population size n is equal to 4 and sample size n is equal to 2. Therefore, 4 raised to power 2 is equal to 16. Possible samples can be drawn with replacement. The list of the possible samples is given as follows. Sample number, sample element. The population size n is equal to 4 and sample size n is equal to 2. Therefore, 4C2 is equal to 4 factorial over 2 factorial into bracket 4 minus 2 factorial is equal to 6. possible samples can be drawn without replacement. The list of the possible samples is given as follows: sample number, sample element, sampling distribution of a sample statistic. If a particular statistic, e.g. sample mean, sample standard deviation, etc., is computed for each of the possible samples, the value of the statistic will differ from sample to sample. Thus, it would be theoretically possible to construct a frequency table showing the values assumed by the statistic and their frequency of occurrence. This distribution of values of a statistic is called a sampling distribution. Thus, we see that there would be an overall mean where it is centered, a standard deviation representing the spread, and a shape if the histogram is plotted. So, we can talk of the mean of sampling distribution of a statistic denoted mean m if m is the statistic, and standard deviation of sampling distribution of a statistic denoted m is the statistic. These properties help lay down rules for making statistical inferences about a population on the basis of a single sample drawn from it, that is, without even repeating the sampling process. In-text question: sampling distribution is the probability distribution of all possible values of a given statistic from all the distinct possible samples of equal size drawn from a population. In-text answer: true. Statistic, estimator, and estimate. Suppose a sample of n units is selected from a population of n units according to some probability scheme, and let the sample observations be denoted by y1, y2 to yn. Any function of these values which is free from unknown population, take 2, which is free from unknown population parameters is called a statistic. An estimator is a statistic obtained by a specific procedure for estimating a population parameter. The estimator is a random variable and its value differs from sample to sample, and the samples are selected with specified probabilities. The particular value which the estimator takes for a given sample is known as an estimate. In-text question: population is the collection of all units of a specified type in a given region at a particular point or period of time is termed as a population or universe. In-text answer: true. Standard error of statistic. The standard deviation of sampling distribution of a statistic is called the standard error of the statistic. It is clearly different from the population standard deviation. The population standard deviation describes the variation among values of members of the population, whereas the standard deviation of sampling distribution measures the variability among values of the statistic due to sampling error. Standard error is a measure of a reasonable difference between a particular sample statistic and the population parameter. It is used in tests of whether a particular sample could have been drawn from a given parent population. It is also used in working out confidence limits and confidence intervals. Difference between standard error and standard deviation. The standard deviation, or SD, measures the amount of variability or dispersion for a subject set of data from the mean, while the standard error of the mean, or SEM, measures how far the sample mean of the data is likely to be from the true population mean. The SEM is always smaller than the SD. When dealing with numerical data sets, many people get confused between the standard deviation of the sample and the standard error of the sample mean. We want to stress the difference between these. Standard deviation SD. This describes the spread of values in the sample. The sample standard deviation S is a random quantity. It varies from sample to sample, but it stays the same on average when the sample size increases. Standard error of the mean, SE. This is the standard deviation of the sample mean and describes its accuracy as an estimate of the population mean. When the sample size increases, the estimator is based on more information and becomes more accurate, so its standard error decreases. In-text question. Standard deviation describes the spread of values in the sample. In-text answer. True. Summary. In this study session, you have learned the following. 1. There are n raised to power n possible samples of size n that can be drawn with replacement from a population having n elements. 2. There are n combination n is equal to n factorial over n factorial into bracket n minus n factorial. Possible samples of size n that can be drawn without replacement from the population having n elements. 3. Sampling distribution is the probability distribution of all possible values of a given statistic from all the distinct possible samples of equal size drawn from a population. And 4. Standard error of statistic measures the amount of chance error in the sampling process. This is the end of study section 2. Thanks for listening.